Okay, in this video we're going to take it one step further, where we use the observed matrix and the expected matrix to work out the chi-squared test statistic. So again, this is something you never do in the exam. Always use the calculator. But in the project, you have to do this to get the full marks for your further mathematical process. When you type it out with maths equation editor that I showed you, it will look something like this, only we're going to use different numbers, of course. So the format is a sum, sigma, that's why it's many terms added together. Each term is an observed frequency minus the expected squared on the top of the fraction, and on the bottom it's the expected. So you can see a kind of a pattern there. These two numbers are the same because they're both expected. So we're going to apply this formula to our matrix. Here we go. So in this cell we say equals bracket observed minus expected squared. And I forgot to divide by the expected. Okay. So observed minus expected squared divided by expected. Then I can just drag that across. Let's just confirm that this does what we want. If I click here, the colors will help you. The blue is the observed. Observed minus expected divided by expected. And then here, we can drag this down and then drag this across, and it still works. If I click here, observed minus expected divided by expected. Now, I've copied this example from page 237 of the textbook, in which you'll find the chi-squared test statistic. Test statistic is 7.79. 7.79. So when I do the sum of all these numbers, it should be 7.79 equals sum. Yeah, it is. Okay. So this gives you a way to manage the data for when you're typing correctly with the right notation your chi-squared test statistic. These two matrices give you the numbers to write in here, and then adding them up gives you a nice accurate confirmation of the chi-squared test statistic. And you can be a little bit careful to avoid errors building up here. This one in the textbook, they chose the numbers very carefully so that they were nice, easy numbers. So there's not as many errors accumulating. However, here we've got lots of decimals with more digits. It would be tempting to approximate these to 3 significant figures everywhere, but think about it, that accumulates data. Errors, I meant, accumulates errors. So when you're writing this up, you may choose to write the numbers with a certain number of digits, because you might not want to write every single thing, but then report what the exact chi-squared test statistic is. That's kind of important, because if you accumulate too many errors, your conclusion in the hypothesis test may be different.